Hi, and welcome to helpyourmath.com. In today's video, we're going to be covering exponents. So, in this problem series, series of problems, we're going to be simplifying the following completely using the properties of exponents. Now, our task is to express our answer using only positive exponents, right? So, I'm going to run a rendition of these problems in two ways. I'm going to do them the long way and then the short way using the properties of exponents so that you can understand why we have to use the properties of exponents. It's not only going to shorten your work, it's going to help you understand algebra a lot better, and you can become a lot more consistent using these properties, all right? So let's begin with our first problem. We have x to the fourth power multiplied by x to the negative sixth power. Now in this case, we know negative exponents have to move to the denominator. So we have here x to the fourth times x to the negative sixth. So we're going to move the exponent to the denominator. And we get x to the fourth over x to the sixth. Now from here we just have to simplify. So if we factor the denominator with the common factor of the numerator, we get x to the fourth over x to the fourth times x to the second. Because there are 6 x's multiplying here, so if we separate them into 4 times the other 2, these will reduce perfectly, because anything over itself gives you 1, right? So these reduce and we get a 1 and a 1 here. So this results in 1 over x squared. Now I didn't use any other properties of exponents except for the negative rule here, right? Whenever you have a negative exponent, you want to move it to the denominator. So x to the negative n becomes 1 over x to the n when we move it, right? When it transposes to the denominator. So here let's try using that rule to see if it helps us do this a little faster. Or actually we're going to use the addition rule, right? X to the n times x to the m gives us x to the n plus m. So here we just have to add up the exponents to get the new exponent. And when we multiply these two, we have x to the fourth plus negative 6 is the exponent. This gives us x to the negative second, which then we use this rule to move it to the denominator. That gives us 1 over x to the second, which is a lot easier to do. You can cut a lot of these steps out as well, just by saying you can go from here to here, no problem, and once you get here, you just move it to the denominator. So our solution for the first problem, 1 over x to the second, because we cannot have any negative exponents in the solution, right? There's number 1. Now be sure you pause and rewind this video if you're having trouble understanding what I'm doing. Just rinse, wash, and repeat, right? So let's move on to number 2 here. Now in this one, we have a perfect square. We have x to the second power times y to the second power. Now we all know that when we have an exponent, what we do is we just expand the term by putting it as many times as the power says. So we'll be multiplying this very same thing times itself. And again, using the rules of exponents, we're adding the powers, x squared times x squared. We're adding the 2's together. That gives us x to the fourth. Y to the first times y to the first is equivalent to y to the second, because 1 plus 1 is 2. Here's our solution for that, right? Let me just go putting that over here for now. And now let's see it with the properties of exponents here. The properties of exponents say if we have an inside term with an exponent and an exponent outside of the set of parentheses, we multiply the two against each other. So we'll have a to the power of n times m. All right, so let's try that with these. Understanding that the y has a power of 1, right? So we have x squared, y to the first to the second power. We'll be distributing this power to each term. So we have x, 2 times 2 is 4. 2 times 1 here for the y is going to give us 2. And this is a short one step instead of expanding the things out. Now, since it's a monomial, it's kind of simple to expand it, but in the case you had a higher set of numbers in here, it may be easier just to distribute the exponent, all right? And that takes care of problem number 2. Let's move on to number 3 now. Now remember, when using the properties of exponents, the properties add one on top of the other. So using multiple properties at the same time may prove beneficial to you, right? Let's move on to the third one here. So we have 3x to the fourth power, y to the negative second, and this is to the power of 3. Now in this problem, what we want to do if we were doing this correctly would be to move the y to the negative second to the denominator of the term, which results in us getting 3x to the fourth over y to the second. Everything inside the parentheses is now done, so we're going to move on and now carry out the exponents, right? And in this case, we're expanding this 3 times. So we get 3x to the 4th over y squared, 3x to the 4th over y squared, and 3x to the 4th over y squared. Now here, 3 times 3 times 3 will give us 27. X to the 4th, x to the 4th, x to the 4th, they're multiplying, so the exponents add. 4 plus 4 plus 4, that's going to give us 12. And y to the second times y to the second times y to the second, again, the exponents just add, and we get y to the 6th. Now this would be the solution, so I'm just going to drop this over here. We have 27x to the 12th over y to the 6th. And let's see if we could get a shorter way to do this by using the properties of exponents, right? The last property we used was distributing the exponent. So let's rewrite the question here. 3x to the 4th, y to the negative 2nd, and we have the power of 3 out here. Now there's a number in here, right? So there's an exponent on numbers as well. If you don't see the power, you can just add the power of 1. And what we're doing here is we're going to distribute the exponent to each term by multiplying them. So the first multiplication is 3 times 1. So we have 3 to the power of 3. Then we have 4 times 3 for the x. So that 4 times 3 becomes 12. We already see we're getting close to the answer. And here we have 3 times negative 2, which gives us y to the power of negative 6. So we're going to move this to the denominator. And this is going to just get expanded. So 3 to the 3rd power is 27. X to the 12th stays in the numerator. Y to the negative 6 moves to the denominator, and the power changes from negative to positive, like so. And there's our solution. A lot easier than expanding it, right? Same solution, just a lot easier work. Let's get on to the last problem now. This is the most challenging problem. And for this reason, I put an asterisk next to the problem to show the difficulty level, right? So to do this problem, it's probably better that we use the properties of exponents because it just makes the work easier. But let's take a look at what that work means if we didn't use the properties of exponents, right? So here we have 2x to the second, y to the negative 4th power to the second, and 3x's to the negative 2nd power, y to the 3rd powers to the negative 3rd. So initially our first step in this problem is going to be to move the negative exponents to denominators. So here on this side we have the fraction 2x squared, y to the 4th. And here we have, this is squared. Then we have 3, the x goes down, so we have 3y cubed over x to the 2nd. And this is to the negative 3rd power. Now the second step would be to distribute the exponents, right? So here we're distributing the 2 to the 2 goes to the 2nd power. 2 squared is 4. X to the 2nd times 2, the power is multiplied, we get x to the 4th. And finally here we multiply the exponent here as well. So this goes down to y to the 8th. And we're multiplying this by, now in this case we have nothing to do to this part yet because it still has a negative exponent. So what we want to do is reciprocate and take care of this exponential power, right? So when we reciprocate the inside, it becomes a positive exponent. And we get x to the 2nd over 3y to the 3rd. And everything is raised to the positive 3rd power now. And now we can distribute the exponent in, right? So this stays the same. We have 4x to the 4th over y to the 8th, multiplying by x to the power of 2 times 3 is x to the 6th. And this becomes 3 to the 3rd power is 27, right? And y to the power of 3 times 3 is y to the 9th. So here we get 4x to the 10th over, and here we're adding the powers as well. We just added the powers of 4 and 6 because they're multiplying. In the denominator, the y's are also multiplying. So we'll have 27, and y, 9 plus 8 becomes 17. That's our solution for the fourth problem. Now let's take a look at this with the rules of exponents to help us get there faster to the solution. Let's see which one works better for us, right? And you got to remember, for those of you watching, wherever you may be watching from, even though there's 2 different methods to do this, it's about the method that helps you best. It's not about what works best or what looks shortest to do. It's all about what you're most comfortable doing when you're solving these, all right? So even though one consists of more work than the other, maybe the style of work may be more up your alley based on what you have to do. Some of us have strengths and weaknesses everywhere, so based on your strengths and weaknesses, you should choose the way that you want to do this. So we have 2x squared, y to the negative fourth to the second. Let's try this again using the properties of exponents to their best potential. And here we have this to the negative third. So our first step is going to be just distributing the negative exponent to every term, right? Before we begin that, we're going to just move this whole thing to the denominator, right? So this goes down right away because negative exponents. So we have 2x to the second, y to the negative fourth to the second, over 3x to the negative second, y to the third, and this is to the negative positive third. And the reason why we're doing this is simply because when we distribute the negative exponent to the number, we don't want to have a fraction next to a regular term. It would be better to have a fraction of terms so that we get a regular number, not an inverse value. Because when we have a term to the negative exponent, this becomes a fraction. And to have a fraction next to an x means we have 1 over 9 times x, which becomes x over 9. Now we don't want to deal with any of this, so to make it a little easier, it's better just to move your negative term down and then start operating with the distribution of terms, all right? So the first distribution of terms then here is going to give us 2 to the second power is 4. X to the second times 2 becomes x to the fourth. The exponents are multiplying again. Y to the negative fourth power times 2, the exponents are multiplying again. We get y to the negative eighth. That's a lot easier to move. Okay, so now we're going to deal with the multiplication of the exponents in the denominator, where 3 has the power of 1, so 3 to the third power becomes 27. X to the negative second power raised to the third, we're going to multiply these two again. So negative 2 times 3 is negative 6. And y to the third power raised to the third, we multiply again. 3 times 3 is 9, and we get y to the ninth power. Now the last thing to do in this problem is to move the negative exponents either up or down based on which ones are negative. So here we're transposing the negative 6 up so it can become positive, and the negative 8 down so it can become positive as well. So we get 4x to the fourth, and we're multiplying times this term, which is going to move up, and this is going to move down. So we get 4x to the fourth times x to the sixth over 27 y to the ninth times y to the eighth. And now here all we have to do is add up the powers, and we're done. So this becomes 4x, 4 plus 6 is 10 over 27 y to the 9 plus 8, 17, which is the very same solution we got in the last problem, only using the properties of exponents. Thank you.